Friends, welcome back my YouTube channel MS Maths. In this particular video, I will discuss or I will introduce the fluid dynamics. So, what is the fluid dynamics and what is the work of fluid dynamics and what we are going to discuss in the fluid dynamics in the particular video series. So, basically, it is a branch of mathematics or in the mathematics or even we can say that in the physics that will be a fluid mechanics. Fluid mechanics is also a branch of physics and mathematical physics in which we discuss the properties of fluids. We all know that what is the fluids. In our everyday life we have lots of fluids within the environment or within our daily routine. Like from morning, like I'm going to start with the water, that is also fluid. Like in our body, that's are like there are lots of fluids will be there, like enzymes. Blood is also fluid. Tissue, cell, plasma, like that are type of different types of fluids. So all the fluids are basically categorized into two major parts. One is liquid and other one is gases. Before going to the categorization of fluid, I'm going to define the fluid. What is the fluid? So basically, the proper definition of the fluid is basically fluid is a substance. It is a material. It is a substance or material. We can say in case of liquid, or else we can use a generalized word that is a substance. It is a substance that deform continuously. Like the form of the fluid will change continuously under the shearing forces. This is important thing. It deforms continuously with some restrictions. That restrictions are the shearing forces. That like these forces may be friction forces, pressure, etc. So in the fluid dynamics, which is the particular branch of fluid mechanics, we focus on the study of fluids in motion. Basically, we'll discuss the fluids, but in this particular branch, in this particular section, we'll discuss the motion of the fluid. What is the property of the fluid in the motion, in like motion state? And there is a branch of mechanics in which we discuss the basically properties, or in like more generally we discuss the properties of the fluids, that will be fluid dynamics. But if fluids in a running state or if fluids in a flowing state, basically because fluid generally flows, so in this case we'll discuss the motion, the property on the based of property on the based of the motion. Okay, so this is the definition, or like we can start with the definition. That is the what is the definition of fluid dynamics? It is a branch of fluid mechanics that focus on the study of fluid in the motion. Okay, the fluid basically categorized into two part, that is liquid and gases. We all know what is liquid and what is gases. That simple definition we can introduce, or we can have an idea about that liquid, what is the liquid and what is gas. So like simple definition is here. Liquid are one of the which incompressible. Liquids are which incompressible means that the volume doesn't change with the given pressure. Whenever a liquid or a fluid collected in a container, if you are giving the pressure to the container, the liquid will be incompressible in ideal cases, or else basically liquid is incompressible in like 99.99% cases. So liquids are incompressible, that can't be compressed by any given pressure. On the other hand, gases are compressible, means that when there is a change in pressure, there is a change in volume. Sorry, there is a change in basically volume with the given pressure. So we all know that there is a word that is density. Density remains same, or we can in the case of liquid, the density is density basically mass per volume. Okay, mass per volume is the density. In the case of gases, the density is very high because the volume of gases are very high. Okay, in the case volume is low, or like basically density, less density, then volume is higher. In like it is not like proportional relation like between these density and volume. Okay, this is some relation from the like physics and like the concept of the physics. Now we'll discuss the continuum hypothesis of the fluid. That will be an important part in our discussion. Before going to that, there is another part, there is another section in the fluid dynamics, that will be hydrodynamics. Basically, in which we study the motion of incompressible fluids. Basically, it is related to liquids. Fluids, if I'm going to use or if I'm using the fluid word, it is more general. It is like either I can take liquids or I can take basically gases. But in the particular section hydrodynamics, there is the thing that only will discuss on the liquids. We'll focus on the liquids. It means incompressible fluids. Incompressible fluids, that will be hydrodynamics. And like basically hydro is quite related to the water. Okay, so we'll discuss further about it. So to study the characteristic of the fluid, we should know about some concept. We should have an idea about the concept. That is a continuum hypothesis. So what is the continuum hypothesis? Continuum hypothesis basically says that it is a more convenient to treat the fluid as having continuous structure. You know very well, if you have water in a container, you will see all the molecules are within a force, and you will see a continuous pattern in the container. There is like it is a container, you will not see in any case that here is some fluid, and there is a vacuum in this between. Yeah, obviously in atomic structure at the atomic level, there will be space, or there will be quite vacancies will be there. But in general, you will not able to see the vacancy. You will see a continuous portion. If a fluid is there, you will see a continuous portion. So it is known as the continuum theory, continuum hypothesis. So it is more convenient to treat the fluid as having continuous structure, so that at each point we can describe the unique properties and pressure and etc. Like these types of some properties that we can consider, or we can describe these types of unique properties and pressures. Now, velocity of the fluid at a point. So we'll discuss it. What is the velocity of the fluid? How will we find the velocity of the fluid? So if I'm going to take a point in a fluid, like it is we will define with the position vector. We all know that position vector will be r vector. That is nothing but x I cap plus y j cap and z k cap in 3-dimensional. So in this case, the position vector from this is OP. So here is a point P. So it is basically P point and it is O point. The position vector, which is R vector. The points are basically, because R vector is a position vector, then basically the coordinates of the P, that will be X, Y and Z. Now after some time, the particle, obviously the fluid is in a motion, in a state, like it is not in a stationary state. So after delta t time, like time is here the time is t, or I can say at t time, at t time the particle is at p point, and after some delta time the point will be here. I can say this point will be p dash and the coordinates are x dash, y dash, z dash, or else we will denote by the x plus del x, y plus del y, z plus del z. Now in this case the position vector will be with some changes, that will be basically r plus delta r. It is nothing but delta r. The time which is t plus delta t, it is the time at this position, at this particular position vector. So consider a time t, a fluid particle p at OP, it is nothing but r vector, and at time t plus delta t, the same particle has reached at p dash. Same particle has reached at p dash. Now, we all know that OP dash vector is nothing but, if OP vector is equals to r vector, and after some time delta t, it will be r vector plus some delta r vector. Then in the internal delta t, the moment of the particle pp dash. So pp dash, what is the basically vector that pp dash? It is nothing but del r vector. Okay, and so the particle velocity, we know that what is the velocity? It is the change in the position or in the displacement with time. So how can we define that? I say q vector is the velocity of the particle. It is nothing but limit or limiting value. So limit delta t tending to 0 or delta r vector, the change in the position, that is del r, and change in time, that is delta t. So in the limiting value we can define that dr vector dt. Okay, so basically q vector is equals to, I will write the position vector, that is r vector, basically dx by dt I cap plus dy by dt j cap plus dz by dt k cap. Now these all component represent individually a component of the velocity. Velocity is a vector quantity. So basically it is u I cap plus v j cap plus w k cap. I say it is the velocity of the particle. It is the velocity of the fluid particle. Now this is the main concept of the lecture, that velocity of the fluid particle. Now we have some geometrical meaning of the fluid flow that we will discuss in further section. One of the concept is streamline. It is interesting and very basic concept of the fluid. That is basically streamline. What is streamline? It is a line, means where tangent to the instantaneous velocity fluid. Basically it represents the tangent. Like I'm considering like it is a fluid and it is flowing like this, or either I can write like this, it is flowing in this way. It will be uniform always. Now the tangent at a particular point in the instantaneous velocity, like with the direction like this, these lines are represent the streamlines. Or basically we can have an idea with some graphical values, like in this case basically, okay, yeah. So if it is a position vector, or either I can say that it is a fluid flow, and I will take a point that is basically there will be a like triangle, a similar triangle will be there, or I can draw the tangent in the direction like this. This is streamline. Now, I say at point dy, it will be like as, or I can write, okay, yeah, wait. So it is the tangent like this, okay, tangent in this way. Okay, yeah, in the direction of velocity. So this is dx and the point, this is dy, or I can write like this. Okay, so this is the direction that is v and this is the direction that is u, because it is dy by dt and it is dx by dt from this value, because u is equals to dx by dt, v is equals to dy by dt, and w is equals to, okay, w is equals to dz by dt. So by this similar triangle, okay, you can see the like similar triangle. Basically, the relation of the similar triangle, we can find the equation of the streamline, that will be basically by similar triangle dy by dx, the ratio of the this side and this side will be this side and this side. So it will be v by u, because this is nothing but u and this is nothing but v. So it is v by u. So we can have dy by v is equals to dx by u. And we have the velocity q is equals to ui cap plus v j cap plus w k cap is the velocity at point P. So basically q vector and dr vector is parallel. Q vector and dr vector. Q vector is velocity. Dr is the like position vector. Dr is nothing but the change. This is the dr. This is the dr. This is also in the flow direction. Okay. Obviously, like these both are parallel. Velocity in the flow direction and flow, and the direction of the flow is like this, on the right hand side like this. So the velocity obviously in that particular manner. So in vector calculus, if two vectors are parallel, then there will have a cross product. So it is nothing but then q vector cross dr vector is equals to 0. So we can find the determinant value, or the value which will be basically I cap, j cap, k cap, cross product u, v, w, dx, dy, dz is equals to 0. Next, we'll solve it. So we'll get I cap into v dz minus w dy minus j cap, the determinant value I am going to expand this, dz minus w dx plus k cap u dy minus u v dx is equals to 0. I hope you all know how to expand the determinant, how to find the determinant value. Now the addition of all these, or else I can write like this, this will be plus, this is minus, and this will be plus. Addition is 0, it means all the terms will be individually 0. Okay, now v dz minus w dy is equals to 0. So I can write in the manner of the basically dz by w, okay, dy by v. Similarly, the second term will equals to 0. So minus u dz plus w dx equals to 0. It will be basically dz upon minus will get cancelled, upon w is equals to dx upon u, and the third term will be u dy minus v dx equals to 0. So it will basically dy by v and dx by u. Question number 1, 2 and 3. By the equations 1, 2 and 3, we can conclude that dx by u, dy by v, dz by w is the equation of streamline. Is the equation of streamline is nothing but tangent in the fluid direction. Okay. Now, next definition is the path line. Path line. Okay, yeah. There is a one fact about the streamline. It will never intercept. It will never. It will, or it never intercept each other. Okay, next, path line. Path line is basically, it is a line means that traced by a single fluid particle in a fluid flow. If I'm going to take a particle like this, and if the flow is like this, so the line, the path making by this particular point or this particular particle of the fluid, which will be the path line. Okay. Next, streak line and path may be intercept each other. Like there is no like restriction. If there is a particle and there is another particle, if it is like okay, yeah, this type of thing will be there, then the point is there, and like this, and like this. The point or the particle, like one particle is here, one particle is here. The path will be this, and the path of this will be this, and it will intercept here. So this is the basic ideology, basic concept of the path line. Will be like will intercept or may intercept each other. Next line is streak line. It is the line produced by the fluid particle that have passed to a described path of some fixed field. It is defined by the some fixed field, right? There is a restriction of the field. Okay. These three lines are very important to understand the characteristic of the fluid, and these all lines are same for the steady flow. Steady flow means independent of time, and these all are different in transient state or unstate like dependent of time. Okay, so these all are same for steady flow, and for unsteady flow or transient flow, these are different. Okay, so thanks for watching my video. I hope you you are getting this point and you are getting the concept of the fluid. This is the introduction video. We'll continue with the like within the lecture, and before going to further video lecture, you should have a basic idea about the vector calculus, like vector calculus and all the integral theorems of the vector integral calculus, Gauss-Divergent theorem, Green's theorem, Stokes-Curl theorem, and you should have any idea, like some idea about that curves, divergent, Gauss, gradient and all. So thanks for watching my video. Keep watching MX Maths, and to watch these types of video from my YouTube channel, subscribe the YouTube channel, and thank you. Bye bye.